What if one of the biggest scientific topics of our time is built on a fundamental misunderstanding of physics? Well, in this explainer, we're going to dig into a scientific reappraisal of climate change that really challenges the foundations of the mainstream view.
So, let's start with a basic question. Is settled science really ever settled? I mean, think about it. For decades, we were all taught that an airplane wing works because air moves faster over the curved top, creating lower pressure, and poof, lift. Turns out that's not really the whole story, not by a long shot. It's a great reminder that even ideas we think are rock solid can and should be re-examined. And that's exactly what our source material argues needs to happen with climate science.
Here's how we're going to break it down. First, we'll tackle that very idea of settled science. Then, we're going to take a close look at the standard climate model and what our source calls its critical flaws. After that, we'll explore a completely different theory, one based on gravity. Then, we'll get into the nitty-gritty of the temperature data itself. And, to wrap it up, we'll look at what might really be driving our climate.
All right, let's jump right in. Is the science on climate change truly settled? According to the material we're looking at today, the answer is not even close. David Thomas, the author of our source material, really sets the stage with this quote. He says, climate science is presented today as settled. Yet when we step back and examine the evidence, the physics, and the record of climate predictions, a very different picture emerges. So what is this very different picture? Let's take a look.
Now, before we can get to the alternative, we have to understand the theory that's being challenged. This is the standard climate model, often called the anthropogenic global warming or AGW theory.
Okay, what you're seeing here is the IPCC's own energy budget diagram. It shows the sun sends about 168 watts per square meter to the Earth's surface. Simple enough, but here's the part our source really focuses on. See that number for back radiation? The model says the atmosphere sends 324 watts back to the surface. Wait a minute, that's almost twice the energy we get from the sun in the first place. How can that be?
This leads us to what the source calls the back radiation paradox. Think about it this way. You've got a hot cup of coffee, right? Let's say it's 90 degrees. The air in the room is maybe 20 degrees. Can you use that cooler air to make your hot coffee even hotter? No way. That would defy a fundamental law of physics. And yet, this analysis argues that's exactly what the standard climate model claims is happening with our planet.
So this all boils down to one incredibly simple question. Can a colder object heat a warmer object?
The second law of thermodynamics. It's one of the most basic rules in all of physics. It's why your ice cream melts and your soup gets cold. Heat always flows from a hot thing to a cold thing. Always. So the argument here is that since the atmosphere is colder than the Earth's surface, it physically cannot transfer heat to the surface to warm it up.
So why do the numbers in the standard model look so strange? Well, the source claims it's because the model basically treats the Earth like a flat disk. It takes the sun's total energy and just averages it out over the entire surface at once. But in the real world, the Earth is a sphere. The sun is like a spotlight, intensely heating one small area at a time, creating these huge temperature differences that drive all of our weather as that heat moves around the planet.
Okay, so if the standard model has these issues, what's the alternative? Well, our source material says the answer is actually pretty simple, and it has everything to do with gravity.
The key concept here is called the lapse rate. It's just a fancy term for something we all know. It gets colder the higher you go up a mountain. And why does that happen? Because there's less atmospheric pressure up there, which lets the air expand and cool down. It's the same reason a can of compressed air gets freezing cold when you spray it. It's just basic physics.
Now, scientists agree that the Earth is about 33 degrees Celsius warmer than it should be, just based on its distance from the sun. The standard theory says, thank you, greenhouse gases. But this alternative view says, hold on. It argues that this entire 33-degree warming effect is caused by atmospheric pressure and that temperature gradient we just talked about, the lapse rate. No greenhouse effect needed at all.
In this chart, this is what's presented as the smoking gun. It shows that this gravity-based model can accurately predict the surface temperatures of planets all across the solar system, from fiery Venus to the gas giant Jupiter, using only two things: how much sun they get and their atmospheric pressure. The source argues the standard model just can't do that.
So let's talk about water vapor. It's called the most powerful greenhouse gas, right? So the standard theory says more humidity should mean more warming. But according to the source, this chart of real-world data shows the complete opposite. When you look at places with about the same amount of sunshine, the places with higher humidity actually have lower temperatures.
Let me just read that again because it's a direct quote from the source. More humidity, the lower the temperature. That's presented as a huge deal, a flat-out contradiction of what the AGW theory predicts should happen.
Okay, so according to this view, the physics of the standard model is shaky, and a key prediction seems to be backwards. But what about the temperature data? I mean, the warming trend is based on actual measurements, right? Well, maybe it's not that simple.
Now check this out because this is pretty stunning. This graph plots the official adjustments made to historical temperature data against rising CO2 levels. And the correlation is, well, it's nearly perfect. The source points to this as a massive red flag, suggesting that the data is being tweaked to fit the theory instead of the theory being tested against the data. It's a classic case of what scientists call confirmation bias.
The source uses a brilliant analogy for this. Imagine you want to lose weight, but instead of dieting, every month you just secretly turn the dial on your bathroom scale down a little bit. Hey, by the end of the year, the scale says you've lost 20 pounds. But did you really? Of course not. You just manipulated the data. And that's what the source claims is happening with the global temperature record.
And you can see the effect of this right here. This chart shows different official versions of NASA's global temperature data published over the years. Look closely. With each new version, temperatures in the past are adjusted to be cooler, and recent temperatures are adjusted to be warmer. The result? It makes the warming trend look much steeper than it originally was.
And it doesn't stop there. The source brings up other major concerns too, like the urban heat island effect. Cities are just hotter, and that can skew the average. It also points out that thousands of weather stations in rural and colder areas have been dropped from the record. And of course, there's the famous hockey stick graph, which has been at the center of scientific debate for years.
So if the physics are challenged, the predictions seem off, and the data is a mess, what on earth is driving our climate? Well, this perspective argues the answer isn't on Earth at all. It's in the sky.
The source presents this chart as its final piece of the puzzle. It shows that the ups and downs of Earth's temperature line up much better with known astronomical cycles, things like tiny wobbles in the Earth's orbit and changes in the sun's activity, than they do with the rise in CO2 levels. The argument is that these huge natural forces are a much better explanation for what we're seeing. And so we're left with this provocative thought. What if the biggest scientific debate of our generation has been focused on the wrong thing all along? What if the main driver of our planet's climate isn't actually us, but the cosmos itself? That's the question this analysis leaves us to think about.